Welcome everyone to the Inside Java newscast, where we cover recent developments in the OpenJDK community. I'm Nikolai Parlok, and later you get to see Jose Pomar. We're both Java developer advocates at Oracle. Today we got two topics for you. First, the list of JEPs that made it into JDK 17, and second, the release process that governs the work on JDK 17 for the next 3 months. Ready? Then let's dive right in.
Thanks, Nikolai. Indeed, we have the list of the happy selected JEPs, which will make it to the JDK 17. JDK 17 is scheduled for next September, and there are some really cool and exciting features in it. 14 JEPs are selected. Some of them have a direct impact on the code you are going to write, and I would like to focus on this one. My preferred feature is the addition of the sealed classes, which is JEP 409. Sealed classes are part of the Ember project and is one more step towards pattern matching. Speaking of pattern matching, there is one more JEP, the 4A6, which is a preview feature called pattern matching for switch. This is also one more step towards pattern matching. You may be thinking, well, that's one more step plus one more step. Sounds like 2 more steps. How many one more steps do we need to have complete pattern matching? Well, that's a tough question, but there will be more one more steps, that's for sure. So stay tuned for more. These first 2 JEPs will impact every Java developer. Several JEPs are very interesting, but maybe not for everyone. For instance, JEP 415, context-specific deserialization filter. You may remember that Java 9 introduced the concept of deserialization filter to enable the validation of incoming serialized data coming from untrusted sources. You know that serialization may be the source of many security issues, and this filtering is done at the JVM level. This JEP gives you more possibilities in this field than what was available in Java 9. JEP 356 enhances pseudo-random number generators, just does that, adds new random number generators algorithms to the JDK. JEP 306 restores always strict floating point semantics. It has to do with how your floating point calculations are conducted on the floating point unit of your CPU. Sometimes you write your calculation using the float primitive types, but it is really executed in double by this FPU. This can lead to slightly different results. Maybe it's not too bad for application, but maybe it is. So this JEP is there to ease the development of your numerically sensitive code. Some other JEPs are welcomed evolutions of the platform. New macOS rendering pipeline is JEP 382, and the macOS AArch64 port is JEP 391. Some others deprecate or remove old or not that much used features of the platform. This is the nostalgic part of the newscast. RMI activation is removed with JEP 407, and the applet API is deprecated for removal with JEP 398. And that means something for all people that started with Java by writing applets. What you telling me, good riddance? The experimental ahead of time and just-in-time compilers were added to the JDK 9 as an experimental feature are also removed with JEP 410, and the security manager is not removed but deprecated for removal. That's the JEP 411. One more sensitive JEP is JEP 403, strongly encapsulate JDK internals. This JEP is the successor of JEP 396, and it strongly encapsulates all internal elements of the JDK, except for critical internal APIs as defined and listed in JEP 260, which includes Sun, MISC, and Safe. So just to be clear, Sun, MISC, and Safe remains available. And we have 2 more incubator JEPs. The first one, the foreign function and memory API JEP 412, delivered by the project Panama. This JEP aims to bring a replacement of JNI, the Java native interface, with this new API. In a nutshell, this API is about accessing memory outside of the heap and call functions written in another language. You can already do that with byte buffer and JNI, but the patterns given by this new API are safer. So if you need that in your code, you should definitely check this JEP. And the last incubator JEP is the JEP 4.14 Vector API. Nothing to do with Java Util Vector. It's about bringing SIMD parallel computations capabilities to the JDK, which is great. If you want to learn more on this topic, there is an episode of the Java podcast about it with John Rose and Paul Sandoz. There is a more in-depth talk by Sandhya Visvanathan and Paul Sandoz on this topic also, and a newscast by Nikolai Parlog, all available on this channel. And now I need to send you back to the studio, and I can't say I'm super comfortable with it. Nikolai, can I leave it to you?
Today, June 10th, the JDK 17 repo gets forked and ramped down phase 1 starts. But what exactly does that mean? I didn't know myself, so I looked into it, and here's the summary. If you want to know all the details, check out Java Enhancement Proposal 3 on the JDK release process. As usual, you'll find the link in the description. Let's start by talking about the issues, which include new features, all kinds of improvements, as well as bugs, of course. Somewhat confusingly though, the OpenJDK community usually refers to all of them as bugs. Yes, even new features like the ones Jose just described. Sticking with the official terminology used in JEP 3, I'll do that as well, but keep in mind that not all bugs are actually bugs. Anyway, OpenJDK tracks bugs in a Jira instance referred to as JBS, the JDK bug system. In the context of an upcoming release, 17 at the moment, bugs fall into two categories. Current bugs relate to recent work and only affect the upcoming release. Targeted bugs are older. They affect already released JDK versions and are planned to be fixed in the upcoming one. Besides that, bugs have one more property that's important to our inquiry, and that's the priority, which ranges from P1, the most important, down to P5. Now let's quickly talk about the OpenJDK repositories. They're hosted on GitHub under the OpenJDK organization, and there are quite a few of them, but the most important one is the JDK mainline, simply called JDK. And this is where a new releases journey begins. Each June and December, the mainline is forked into a stabilization repository called JDK version number. So today that's going to be JDK 17. The fork works very much like a release branch. This is also the time when the release process officially starts. It stabilizes the upcoming release and minimizes the risk of introducing new problems by only working on increasingly important fixes and an increasingly strict process. Usually, these fixes will be developed in the stabilization fork and then ported to the mainline where other development continues. Rampdown phase 1 starts with the fork and lasts a few weeks. For JDK 17 that's going to be 5. All code-related bugs with a priority of P4 or lower, meaning less important, won't be fixed before the release. Of the remaining P1 to 3 bugs, the focus is on the current ones, meaning those that were recently introduced. Targeted bugs, which remain from older releases, are optional. If a JDK developer deems a bug with priority 1 or 2 to take too long or be too risky, they can use the bug deferral process to potentially push the bug to a later version. In this phase, bugs of any priority that only affect tests or documentation may still be fixed. Rampdown phase 2 works a bit differently from Rampdown phase 1 and tightens the screws. First, only current bugs can be worked on. Targeted bugs will be fixed in the future. Second, the priority requirements are stricter. Priority 3 is out, and only bugs with priorities 1 and 2 will be worked on. For code that goes into the released JDK, that is, test and documentation bugs of all priorities can still be fixed. And third, the fix request process must be used to decide whether a bug will be worked on. This process involves a group or area lead who will help make sure that fixing the bug in the upcoming release is a reasonable idea. For JDK 17, Rampdown phase 2 lasts 3 weeks until August 5th. And on that fine first Thursday in August, the first JDK 17 release candidate will be built. After that, only the most critical bugs can be addressed. To be fixed, a bug must be current, it must be priority 1, it must have passed the aforementioned fixed request process, and it must actually impact released code. The hurdle is intentionally steep to make sure the release candidate is kept stable. But if further bugs are discovered and fixed, new candidates will of course be released. Hopefully all remaining problems will be found and fixed within the next 2 weeks, so that on August 19th the final release candidate can be built. And that's it. Ideally, while more and more projects start building against the release candidate, nothing critical is found, and after a few weeks, 4 in this case, the new JDK version reaches general availability and the release candidate is promoted to be the actual release. For JDK 17, that's going to be September 14th. 17 is of course also the next long-term support version, and we plan to go into this as well, but you've suffered through enough process details for one episode, so we'll talk about that one in 2 weeks. And if a lengthy explanation of who fixes what and which forks isn't a reason to subscribe, I honestly don't know what is. And that's it for today on the Inside Java Newscast. If you have any questions about what Jose and I covered in this episode, ask that in the comments below. And if you enjoy this kind of content, help us spread the word with a like or by sharing this video with your friends and colleagues. I'll see you again in 2 weeks. So long!